Welcome to another AI pattern recognition deep dive.
Okay, let's unpack this. We are diving into sources today that map out, well, a profoundly complex cognitive double-bind. It's like this hidden set of rules the human brain uses to judge others, specifically deciding when race matters and when it just gets ignored.
It's really incredible research, actually, because
Wow.
it moves beyond just general ideas about implicit bias.
Yeah.
It formalizes a specific pattern they call the Conditional Racial Saliency pattern, or CRS.
CRS, okay.
Yeah, and it details the precise cognitive tricks we use, maybe unconsciously, to cope with evidence that might otherwise force us to confront, systemic unfairness.
So our mission today is to really get into the computational work being done to calculate this pattern. They want to formalize exactly when race becomes salient, visible, right, for negative judgment, and conversely, when it's kind of brushed aside.
Exactly. And the core finding here, and this is what makes the CRS pattern so, insidious, is its paradoxical nature. Race becomes hypersalient. It jumps right out when it's linked with negative outcomes. Things like perceived aggression, maybe deviance, or incompetence. But that same racial identity is essentially disregarded. The research calls it deracialized when the person shows really high competence. Exceptionally high.
Right. So if you're a professional from a marginalized group and you, say, make a mistake, your race can suddenly become the main explanation for that mistake.
It can become the anchor, yes, the go-to internal attribution.
But if you achieve something huge, something undeniable,
then the brain treats that success almost like an anomaly, an individual thing. It lets the observer think, see, meritocracy works, conveniently proving the rule by highlighting the exception.
wow, that's subtle.
It's fascinating because it suggests this isn't just random prejudice. It seems to be a structured cognitive maneuver. Its function appears to be preserving the observer's belief in a fair, just system. It's like an incredibly efficient mental loophole.
A loophole that lets you explain away success without having to admit structural bias might exist.
Precisely. It avoids that cognitive dissonance.
Okay, let's get to the bedrock of this.
Okay.
We need to ground it in some classic social psychology, right?
Definitely. To really grasp CRS, you have to start with attribution theory. It's the basic framework for how we, as humans, figure out the causes behind what we see.
Right, why did that happen? Why did they do that?
Exactly. And we tend to sort causes into two buckets. Internal, meaning something about the person, their character, ability, effort. Or external, meaning something about the situation, the environment, context, maybe just bad luck.
And humans are, well, notoriously bad at applying this fairly. Which brings us to that famous cognitive bias, the fundamental attribution error, FAE.
That's the one, sometimes called correspondence bias. It's our default setting, you could say. FAE means we instinctively, often without thinking, over-attribute what people do, especially negative stuff, to their stable internal characteristics. That's just who they are.
A character flaw.
Right. And we systematically neglect, or at least downplay, powerful situational factors that might have been the real cause.
It's the classic double standard, isn't it? If I mess up, it was the traffic, the computer crashed, my boss gave me bad info, external stuff. But if you mess up, well, clearly you're disorganized or lazy or not smart enough internal stuff.
That's FAE in a nutshell. And the CRS pattern is basically the racially charged application of this deeply ingrained thinking error.
So we don't apply the FAE randomly when race is involved.
It seems not. When we encounter someone who fits a certain pre-existing social category or script, we apply it conditionally, based on that social identity.
Okay, let's break down the two poles of this conditional mechanism you mentioned earlier, the competence override and the deviance activation. Can you start with the competence override?
Sure. The override feature is really key to understanding this idea of system justification we touched on. So when someone from a marginalized group shows competence, and we're talking exceptional competence, not just average.
Really stands out.
Yes. The observer attributes that success internally. Wow, they're brilliant or incredibly hardworking or just naturally talented. The success is so undeniable, it actively overrides the negative stereotypes that might usually be associated with that person's group identity.
And that successful person is then cognitively sort of deracialized. They become the exception.
That's the term used, yeah.
But hold on, isn't praising success a good thing? I mean, recognizing individual achievement. Are we saying that's part of the bias mechanism itself?
It absolutely can be, especially when you look at it through the lens of system justification theory, or SJT. From the SJT perspective, the brain's goal here isn't just accuracy. It's often self-preservation of its worldview. protecting the status quo.
How does praising someone protect the status quo?
By isolating the success.
Yeah.
By treating the successful person as this purely individual dispositional phenomenon, the exception that proves the rule, the observer neatly avoids confronting the uncomfortable possibility of structural bias.
Ah, I see. So by celebrating that one individual, I can comfortably keep believing the overall system is fair for everyone. I can say, look, see, person X succeeded. So the system works. Anyone can make it if they just try hard enough.
Precisely. That success story becomes the convenient evidence used to dismiss or ignore the systemic obstacles that might be holding back others from that same group. It allows systemic denial to persist.
Wow. That is a powerful cognitive defense
It's
mechanism.
incredibly efficient, yeah.
Yeah.
Against evidence that might challenge fundamental beliefs about fairness and meritocracy.
Okay, now let's flip the coin, the inverse. Deviance activation. This is where race suddenly snaps into sharp focus.
Right. So when that same individual who might have been previously deracialized due to competence exhibits behavior that gets categorized as deviant, and the sources use quite evocative terms here like strange or dumb, abnormal, aggressive, or insulting.
Subjective terms, definitely.
Very subjective. But when behavior hits one of those triggers, the fundamental attribution error kicks in instantly. The observer needs a quick internal explanation for this negative behavior.
And because our brains are basically shortcut machines.
Exactly. Social perception loves shortcuts.
Mm.
And unfortunately, racial and cultural stereotypes, constructs tied to historical inequality, are readily available mental shortcuts. They become the immediate, convenient dispositional proxy. The quick answer for why.
So this is the moment of activation.
Yeah.
The negative behavior makes race salient.
It triggers the racial saliency, yes. And that saliency then anchors the negative internal attribution. It solidifies the it's because of who they are explanation.
And the research shows this links to broader explanations.
It does. Studies show that when people are asked to explain group-level disparities, that differences in income, education, health outcomes between racial groups, observers who activate this CRS pattern often shift their explanations away from structural factors like historical discrimination or lack of opportunity
And
towards inherent cultural traits or character deficiencies attributed to the marginalized group itself. It's their culture, or they don't value education, things like that.
so it becomes the ultimate cognitive deflection. Blame the individual or the group's disposition instead of the system.
Precisely. It locates the problem within the marginalized group, conveniently ignoring external factors.
Okay, this is where it really hits home, because this isn't just abstract psychology, is it? This mechanism, the CRS pattern, seems to play out constantly in really high-stakes situations, anywhere assessment happens, basically. Performance reviews, courtrooms, even doctors' offices.
Oh, absolutely. The workplace is a prime example. Think about performance evaluations. We already know about affinity bias, right?
Yeah, where managers unconsciously favor people like them. Same school, same background, whatever.
Right, and that often translates to an automatic internal attribution of competence. They're good because, well, they're like me.
Okay, now let's contrast that. Imagine a majority employee makes a relatively minor, fixable mistake. Maybe sends an important email with some missing info.
Typically what happens, that error often gets attributed situationally, externally.
Like, oh, they must have been really rushed today, or the instructions weren't clear, or, yeah, communication's been messy this week. External factors.
Exactly. Now, the error trigger. Imagine an employee from a marginalized group makes the exact same small mistake.
Here comes the CRS pattern.
This is where it seems to activate. The error is instantly internalized and potentially racialized. It leads to attributions of fundamental deficiency. They lack attention to detail. Maybe they aren't capable of handling this level of complexity.
Or the really damaging one. Maybe not a good cultural fit.
That one's killer. The racial component gets activated to anchor this enduring negative judgment, turning a small error into evidence of inherent lack of capability.
And it's so insidious because the person making the judgment might genuinely believe they're being objective.
They often do. They're just following this ingrained cognitive pattern.
And then institutions apparently liked this pattern so much they started automating it. You mentioned the justice system. Tools like Compass.
Yes, the Compass risk assessment algorithm became a very high-profile example of basically digitizing this human correspondence bias, turning it into code.
How did it do that?
Well, ProPublica's investigation, among others, showed it was incorrectly flagging Black defendants as high risk for reoffending at a significantly higher rate than white defendants who had similar criminal histories and risk factors.
So the criminal offense, the observed deviant behavior, triggered an automated negative racial attribution.
Essentially, yes, because the algorithm was trained on historical crime data, and
Yeah.
that data itself reflected decades of biased policing, sentencing disparities, and socioeconomic factors that were already correlated with race. The algorithm learned that race was a statistically convenient proxy for future risk, without understanding the why behind the correlation.
It's the computational FAE. The machine, just like the human observer sometimes, fails to properly account for the situation. Poverty, policing patterns, lack of opportunity, and instead it just defaults to the easily available correlated variable race.
Precisely. It mistakes correlation for causation on an industrial scale.
And this isn't just in justice, you said healthcare too.
Yes, similar problems arise there. Think about AI tools being developed for complex diagnostic tasks, like spotting skin cancer from images.
Okay.
If the AI is trained almost entirely on images of light skin, because historically, medical datasets have been overwhelmingly skewed towards non-Hispanic Caucasian patients, then a purely technical limitation, the lack of diverse training data, translates directly into a prejudicial health outcome.
How so?
The AI is simply less accurate at identifying suspicious moles or lesions on darker skin. It hasn't seen enough examples.
So the lower accuracy isn't seen as a flaw in the AI.
It can get misinterpreted. The tool might fail to flag a real cancer, or it might flag benign things more often, leading to unnecessary procedures. The technical failure impacts patient care differently based on skin color.
Wow. All of this really underscores the central problem with standard predictive machine learning models, doesn't it? We used to think of them as purely objective.
They seemed objective because they use math, right? But they have a fundamental limitation. Predictive AI is fantastic at finding correlations, telling us when X and Y tend to happen together. When X occurs, Y is likely. But it fundamentally cannot identify causation. It can't tell us why X leads to Y. It doesn't understand the underlying mechanism.
So the AI spots a correlation, maybe between a negative outcome like reoffending Y and a variable like race or zip code,
Yeah.
X. And because it's only built to predict, it commits that computational fundamental attribution error. It treats the correlation itself as the root cause.
Yes, it treats X as if it's the inherent dispositional reason for Y, because that's the pattern it found in the biased data it was fed.
And you mentioned a really devastating real-world example of this in healthcare software.
Yes, a study published in Science looked at a widely used algorithm designed to predict which patients would need extra medical care. A sensible goal.
Sounds useful. How did it predict need?
It used historical healthcare spending as a proxy for health need. The logic, seemingly, was people who cost more in the past are likely sicker and will need more care in the future.
Okay, that seems logical on the surface. But I sense a but coming.
A huge but. Because historical healthcare spending is profoundly confounded by systemic factors, especially racism and access barriers.
So the model failed because...
It failed catastrophically because it ignored the reality that, due to things like lack of insurance, mistrust of the medical system based on past experiences, geographic barriers to accessing care, and doctors' own biases, Black Americans historically have lower healthcare spending than white Americans, even when they're suffering from the same chronic illnesses.
So the AI read low spending.
As low health need, it mistook a symptom of systemic racism and access barriers for an indicator of good health.
Oh my God. What was the outcome?
The outcome was that significantly sicker Black patients were flagged by the algorithm as being lower risk than healthier white patients.
So they were denied access to programs.
They were systematically less likely to be enrolled in care management programs designed to help patients with complex health needs. The AI essentially automated and amplified systemic neglect because it couldn't ask the causal question, why is the spending low?
That's horrifying. And it perfectly illustrates this feedback loop problem too.
Exactly, the algorithmic feedback loop.
Right.
When these biased outputs, like a skewed risk score leading to someone being denied parole or denied extra care, get recorded and fed back into the system as new input data for the next version of the algorithm.
The algorithm doesn't go, wait, maybe that was wrong.
No, it just sees, people like this do end up denied paroles, or people with low spending do end up not getting extra care. It learns the biased outcome as if it were the correct pattern.
So it perpetuates and actually amplifies the original human bias, locking in systemic inequalities.
Precisely. It becomes a cycle that's very hard to break using predictive models alone. So if you look at the sheer severity of this computational FAE, the fact that these predictive models are, frankly, fundamentally incapable of operating ethically or accurately in sensitive social areas like justice or healthcare, it really forces us towards a different approach, a foundational shift in how we use computation in these domains.
We have to move beyond just predicting what happens.
To actually explaining why it happens, understanding the cause and effect relationships.
And this is where causal AI comes in. That's the mandate, right? Moving from what's likely to happen to what's the specific impact of this one factor.
Exactly. Causal AI models are designed specifically to identify these cause and effect links. They aim to explain why people behave as they do, or why certain outcomes occur. This allows us to pinpoint the actual levers we can pull for effective change, whether that's policy changes or targeted interventions, instead of just, reacting to surface-level correlations or symptoms.
So if we want to truly formalize this conditional racial saliency pattern to calculate how much an observed negative behavior actually causes a racialized judgment, while controlling for all the situational stuff, boy, Kat, that sounds like it would require some seriously sophisticated causal AI techniques.
It absolutely does. We're talking about approaches like causal Bayesian generative modeling, causal BGM for short.
Okay, causal BGM, how does that work in simple terms?
Well, think of it like building a map. Causal BGM often uses a graphical approach, maybe something like a directed acyclic graph, or DAG. This DAG explicitly maps out the assumed network of relationships between all the relevant variables. Crucially, it forces the model builders to think about and represent potential confounders, things like poverty, neighborhood safety, past experiences with discrimination as upstream causes that influence both the behavior and the outcome, rather than just being correlated noise.
So it's not just drawing a simple line from race to judgment. It's mapping the whole complex web. Situation A affects stress level B, which influences behavior C, while identity D influences how observer E perceives C, something like that.
That's the idea, mapping all the potential causal pathways and trying to estimate the strength or weight of each path. It ensures that a variable like race is treated as one factor within a complex system, not just the single, simple explanation.
And within this causal BGM framework, you mentioned estimating something called the ITE.
Right, the individual treatment effect, or IT, this is really crucial. The ITE tries to isolate the specific effect of a particular treatment or variable in our case, maybe the effect of the individual's race on the observer's judgment for that specific individual, considering all their unique characteristics and context.
How does it isolate that one effect?
This is where causal AI gets really powerful. It uses the concept of counterfactual simulation, asking the what-if question that, as we discussed, the human brain often avoids when justifying biases.
The ultimate what if. Okay,
Mm-hmm.
give me an example.
Okay, let's take the scenario. An individual from a marginalized group behaves in a way perceived as aggressive in a specific situation. The causal AI, using its map and ITE estimation, can simulate a counterfactual world. It asks, okay, what attribution would the observer have made if this exact same individual in this exact same situation with the exact same stress level, exact same prior interactions? What if their race were hypothetically different?
While keeping literally everything else constant.
Everything else constant. That simulation allows the AI to computationally isolate and quantify the marginal causal effect specifically attributable to the racial saliency aspect of the judgment.
That's the key, isn't it? It forces the system, the computational system, at least to admit that even when you control for everything else that could possibly explain the behavior, changing just the race variable still changes the outcome judgment.
Precisely. It quantifies the bias that remains after accounting for situational factors. It's how we can computationally break the FAE and the CRS pattern.
And doing this kind of analysis, this causal modeling, it seems like it would have to be much more transparent than the black box predictive models we hear about.
That's a huge advantage, yes. Causal AI models, by their nature, because you have to explicitly define the causal structure, the DAG tend to offer much greater transparency and interpretability. You can usually inspect the model's assumptions, see the pathways it's considering. Plus, they often provide more comprehensive ways to quantify uncertainty around the estimates.
Which is critical in sensitive areas like this.
It's ethically non-negotiable, really, especially when you're trying to model and mitigate something as subtle and impactful as the CRS pattern. We need that transparency for accountability. It lets researchers, policymakers, affected communities scrutinize the model's reasoning, audit it for hidden biases that might have crept into the assumptions or the data.
We can't afford opaque systems making these kinds of life-altering decisions.
Absolutely not. The shift from just predicting risk to actually explaining the causes of observed behavior or outcomes isn't just a technical upgrade. It feels like an ethical requirement.
Okay, so causal AI offers a path forward. But building these models to accurately capture something like the CRS pattern, sounds incredibly difficult. The technical challenges must be immense, especially if you want to calculate this across all demographics, different ages, genders, sexual orientations, cultural backgrounds, everything. You can't just run a simple survey.
No, the scale required is enormous. Traditional data collection methods would likely fall short. This is where generative AI agent architectures come into the picture.
AI agents, like simulated people.
Sort of. Think of highly advanced large language models that have been trained not just on text, but on detailed human interaction transcripts, sociological data, psychological profiles. These AI agents can be designed to simulate complex human behaviors, attitudes, decision-making processes, including attribution biases, across thousands or even millions of simulated individuals in various contexts.
So you can run large-scale virtual experiments.
Exactly. It gives us the statistical power and scope needed to start quantifying these complex patterns across diverse populations in a way that real-world data collection might struggle to achieve ethically or practically.
But within that scope, there's another huge complexity: intersectionality. You can't just add up biases, right?
Absolutely not. That's a critical point. Social identities, race, gender, class, orientation, disability status, etc., they don't just exist side by side, they interact. And the bias experienced by someone at the intersection of multiple marginalized identities is often not just additive, it can be multiplicative or exponential. It's a nonlinear interaction.
So the bias against, say, a black woman isn't just bias black plus bias woman.
Correct. It's often significantly greater, a unique form of bias stemming from that specific intersection. The CRS saliency triggered by an abnormal behavior from a black man might be causally different from the saliency triggered by the same behavior from, say, an elderly Latino woman or a young gay Asian man.
So the causal AI model has to be sophisticated enough to capture and isolate these unique non-additive interaction effects for every relevant intersection.
That's the goal. It adds layers of complexity to the modeling, definitely. Requires very careful data structure and analysis.
Okay, so that's the complexity of the people being modeled. What about the complexity of the trigger? You mentioned the labels themselves: strange, dumb, abnormal, aggressive. These are incredibly subjective.
This is perhaps the single biggest challenge: the annotation trap.
The annotation trap. Explain that.
The critical problem is that these trigger variables are fundamentally subjective. What one person considers aggressive, another might see as assertive or even understandable given the situation. It varies dramatically based on the observer's own background, their cultural lens, their personal experiences, their own implicit biases.
So if the causal AI needs data to learn specifically where behaviors are labeled as aggressive or abnormal, and you rely on humans to provide those labels,
then the whole process risks becoming a dangerous self-fulfilling prophecy. You're essentially asking humans, who are potentially subject to the very CRS bias you're trying to model, to label the data.
Oh, wow. So they'll just inject their own bias right into the training data.
That's the core labeling bias issue. Human annotators, influenced by their own implicit CRS patterns, are likely to systematically, maybe unconsciously, apply negative labels like aggressive disproportionately when observing the behavior of someone from a marginalized group compared to someone from a majority group in the exact same situation.
And the AI, being a pattern-finding machine,
Will simply learn that correlation. It will learn race X is correlated with the human label aggressive. It won't learn objective truth about the behavior. It learns the bias of the human labeler.
so you end up building this authoritative-seeming computational system that doesn't eliminate the bias, but actually formalizes and potentially amplifies the systemic discrimination inherent in the original human CRS pattern.
Exactly. It launders human prejudice through a computational process, making it seem objective.
That's deeply problematic.
Yeah.
How do you even begin to mitigate that?
It's incredibly difficult. The most promising approach seems to be moving towards what's called context-aware annotation. Maybe something like the situ-annotate concept. This means you don't just collect the label, aggressive, you have to capture rich situational data alongside it.
Like what?
Like detailed information about the annotator themselves, their background, their cultural context, information about the environment where the behavior occurred, maybe even the annotator's own stated perception of threat or stress during the observation.
So the AI isn't just learning the label, it's learning who applied the label and under what conditions.
Right. The AI has to be explicitly trained to consider the source of the label and its potential biases as part of the input. It needs to learn to mitigate the confounding effect of the annotator's subjectivity to get closer to the underlying pattern of behavior itself. It's about modeling the annotation process itself.
That adds even more complexity.
It does. And finally, layered on top of all this is the persistent issue of data imbalance.
Right, you mentioned the healthcare AI trained mostly on white skin.
Exactly. We know that many current AI models, especially in clinical and social domains, vastly overrepresent data from non-Hispanic Caucasian populations. Now remember that the CRS pattern often gets triggered most strongly in these complex outlier cases, the moments of high stress, ambiguity, perceived abnormality.
Okay.
If the AI hasn't been trained on enough diverse data, especially data representing these kinds of stressful or unusual interactions for underrepresented groups, it simply won't generalize well.
It won't accurately assess the situation or the competence level for those groups.
Potentially not. It might struggle to recognize situational stressors or interpret behavior correctly for individuals from groups it hasn't seen much data on, which, guess what? Reinforces the tendency to default back to the readily available biased shortcut, the racialized negative attribution. The FAE strikes again computationally.
Okay, so we've mapped the bias, the computational flaws, the immense technical hurdles. What's the end game here? Is the goal just to calculate this pattern, or is there something more?
Oh, there's definitely something more envisioned. The ultimate, really profound goal isn't just to measure the bias, however precisely. It's to use that quantification to design an intervention, something that could actually help us, as humans, move past this default cognitive flaw. It sounds ambitious, but some researchers frame it as potentially facilitating another step in human social evolution.
Evolving past the FAE in this context.
Exactly. This requires what they call a teaching humans framework. The intervention has to be explicitly designed to disrupt the fundamental attribution error as it happens. It needs to help the observer understand, maybe viscerally, that the negative behavior they just saw, the abnormal or aggressive act, is often primarily a symptom, a proximate outcome.
The symptom of what?
Of deeper external structural factors, things like the cumulative weight of historical discrimination, current poverty, systemic resource scarcity, a constant barrage of microaggressions, maybe chronic anticipatory stress from knowing you might be judged unfairly.
Rather than it just being an inherent personality defect tied to race.
Precisely. Shifting the attribution from internal disposition to external situation.
And this framework needs to combine, what? Sociology and AI.
Yes. It needs to synthesize those deep philosophical and sociological insights about structural inequality with the causal AI's computational power, specifically targeting what you might call structural ignorance, helping people expand their definition of bias beyond just overt conscious hatred to recognize these pervasive, often invisible structural forces that shape behavior and outcomes.
Okay, so how do you deliver such a complex lesson? You can't just show people a chart, right?
Probably not effectively, no. The research points towards immersive virtual reality IVR as potentially the optimal delivery mechanism.
VR. Why VR?
Because IVR allows for truly embodied perspective taking. It's not just watching a video or reading a story. It lets users literally, visually, spatially inhabit the experience of someone else. Specifically, inhabiting the role of an avatar representing someone from a marginalized group, navigating a complex, potentially biased environment, say, a Black professional in a high-stakes meeting.
So you feel like you are that person experiencing what they experience.
That's the goal, to build that critical baseline of empathy and understanding before the intervention trigger happens.
Okay, let's walk through this conditional attribution journey, the AI intervention in action. You said it operates in phases. Phase 1 is the baseline.
Right, phase 1, competence baseline. The user, embodied in this marginalized avatar, first performs a series of tasks that demonstrate clear competence, maybe complex problem-solving, skilled communication. This establishes a neutral or positive attribution baseline in the user's own mind about their avatar's capability before any stress is introduced.
Okay, baseline set. Then phase 2, stress deviance activation. This is where you intentionally trigger the CRS pattern.
Yes. The user's avatar is then systematically subjected to escalating, often subtle, nuanced situational stressors.
Like what kind of stressor?
Maybe encountering institutional barriers, paperwork that's harder for them, resources they can't access, or a rapid series of microaggressions from simulated colleagues, maybe being constantly interrupted or having their ideas dismissed. This builds until it culminates in a moment where the user's avatar has a public observable reaction. A reaction that an external observer, programmed with typical biases, would likely classify as abnormal or aggressive or emotional.
The trigger moment.
The trigger moment. And then comes phase 3, real-time causal correction. In the simulation, other characters, non-player characters, or NPCs, but implemented as sophisticated generative AI agents trained on real-world bias data, observe the avatar's reaction.
And they react negatively.
Yes, they immediately assign dispositional blame. They might say things like, see, I knew they couldn't handle the pressure, or that was really unprofessional. They activate the CRS pattern, reflecting common real-world biased judgments. This acts as a kind of cognitive mirror for the user.
But then the causal AI steps in.
Immediately. The embedded causal AI, which has been tracking the avatar's experiences and its own internal model of the situation, provides immediate, personalized, quantified feedback directly to the user.
Quantified feedback, like a score.
Like a quantified attribution. It might pop up as text or audio saying something like, the causal AI estimates that 78% of your avatar's reaction was caused by external factors, specifically the cumulative effect of 7 documented microaggressions and 2 institutional barriers encountered in the last 10 minutes, not by inherent disposition or race.
Wow. It gives you the percentage breakdown of cost.
That's the idea. It provides undeniable quantified evidence calculated by the causal AI's ITE analysis, directly confronting the user's likely FAE impulse at the moment of attribution. It doesn't just say, consider the situation. It says, here is the data showing the situation was likely the primary driver. It forces the user to confront the specific structural determinants that led to the behavior they just enacted through their avatar.
That feels like it could be incredibly powerful, disrupting the bias right as it forms.
That's the hypothesis. It computationally dismantles the FAE-CRS mechanism at the point of impact.
But we know that the effects of VR experiences, even powerful ones, can sometimes fade over time. How do you make this stick? How do you get long-term change?
That's a critical question. Just presenting the data, even quantified causal data, might not be enough for deep, lasting change. The system likely needs to do more. It probably needs to integrate sophisticated emotional intelligence frameworks.
Emotional intelligence for the AI.
Yes. The system would need to process multimodal emotional signals, perhaps the user's vocal tone, their physiological responses, if sensors are available, their choices within the simulation to understand the user's emotional state. The goal would be to link the cognitive correction, the quantified causal feedback, to the user's emotional experience of empathy or dissonance within the IVR environment.
So connecting the logical understanding with an emotional resonance.
Exactly. To help ensure that the core lesson that context, situation, and structure profoundly mediate perceived deviance isn't just an intellectual takeaway, but gets cemented into longer-term internalized behavioral norms, leading to hopefully genuine, sustained empathy and ultimately changed decision-making in the real world. Now, it goes without saying, developing an AI system, this powerful one, capable of modeling, quantifying, and then actively intervening in something as sensitive as racial discrimination, carries absolutely enormous ethical risks.
Huge risks.
Yeah.
And potential legal liabilities too, right?
Yeah.
Especially with new regulations coming online.
Definitely. Think about something like the EU AI Act. A system like this would almost certainly be classified as high risk, demanding incredibly strict assessment, transparency, and human oversight requirements. Failure could lead to massive penalties, let alone the societal harm.
So governance and oversight aren't optional here. They're fundamental.
They have to be built in from the start. We'd need, ideally, some kind of transnational, independent governing body. This body would need to perform continuous, rigorous bias impact assessments throughout the entire life cycle of such an AI, from data collection and model design to deployment and monitoring.
And what should those assessments focus on?
Critically, they need to scrutinize the inputs and the assumptions, especially ensuring that those latent confounders, the causal AI, uses all those nuanced variables like neighborhood characteristics, school quality, historical redlining effects, that these variables aren't just subtle, complex proxies for race or socioeconomic status themselves. We have to be incredibly careful not to inadvertently perpetuate the very biases we're trying to eliminate, just hidden under a more complex model.
Auditing the inputs and the causal assumptions, not just the final output code.
Exactly. Deep, ongoing scrutiny is essential.
Okay, so pulling it all together, the synthesis here seems to be that this causal AI system, especially when deployed thoughtfully through something like IVR, could act as this undeniable, quantified cognitive mirror.
Yes. It has the potential to computationally break the observer's reliance on the CRS pattern as a tool for maintaining system justification. It forces a confrontation with structural reality, backed by data.
It moves us away from just predicting correlations
Towards understanding definitive causative factors. And that shift, as we've discussed, feels like more than just a technical advancement. It feels like an ethical imperative for any system making life-altering decisions, whether in justice, healthcare, employment, or education. It offers a potential pathway, however complex, towards seeing people based on their shared humanity rather than through the distorting lens of race conditioned by centuries of systemic prejudice.
That structural view really is the core lesson, isn't it? We're learning, or relearning with computational rigor, that the problem often isn't the isolated individual behavior we see.
It's the specific, often invisible, but quantifiable environment and history that shapes that behavior.
And being able to quantify those environmental and structural causes, that allows us to design much more precise and effective solutions, presumably.
That's the hope, moving from blaming individuals to fixing systems.
Which leaves us, and you listening, with one final thought to really chew on as you process this deep dive. What systemic barriers, things that currently appear to us as individual failings, whether it's poor performance at work, higher rates of contact with the justice system, or even lower healthcare spending, how would our understanding of those issues be completely redefined?
Yeah.
And maybe more importantly, how would our policies and solutions change if we could truly quantify the precise situational and structural causes driving them?
Thank you for joining us.
Yeah.
We'll see you soon.
This is DigitView.